Hello everyone and welcome to this video lecture on coordinate geometry, the distance formula. Before breaking on to the chapter, let us first introduce ourselves to it. What is coordinate geometry? Well, it is the branch of mathematics in which different problems of geometry are solved with the help of algebra. We know what algebra is, wherein we use different variables and solve equations by substituting values. When we apply algebra in 2 or 3 dimensions, we get coordinate geometry. Coordinate geometry is of 2 types. 2-dimensional geometry based on any plane region. For instance, a blackboard, a whiteboard, a piece of paper. 3-dimensional geometry. This is based on a solid object, such as cube, cuboids, spheres, cylinders. To get an analogy of 2-dimension and 3-dimension, circle is a 2-dimensional figure, whereas a sphere is a 3-dimensional figure. To put that into perspective, a CD or a compact disc is a 2-dimensional object. A ball is a 3-dimensional object. Moving on to concept of a plane. As we can see here, there are 2 lines that intersect each other at the center. We denote them by X, O and Y. Always remember, as an international standard of convention, the horizontal line is always the X line. The vertical line is always the Y line. The point at which the horizontal and the vertical line intersect is called O, or origin. This particular part of the graph is called the first quadrant. It is positive and positive. That is, the value on the X line and the value on the Y line are both positive. Extending the line beyond O gives us X dash. From O to X dash, the value of X is negative. This produces the second quadrant. The value of second quadrant is always negative and positive. This gives us a fair idea that whenever we denote a point on the plane, the value of X is always put first, followed by the value of Y. This is again not interchangeable and is a standard protocol. The value of X is always put before the value of Y. That is the reason why in the second quadrant, by putting the negative value of X first, we get minus first, and then the positive value of Y, we get positive. The Y line or the Y axis beyond O gives us Y dash. This results in the third quadrant, wherein the values of both X and Y is negative, because we are taking the value of X from O to X dash and the Y from O to Y dash. The value of X from O to X dash is negative. The value of Y from O to Y dash is also negative. As a result, points lying in the third quadrant are both negative. We are left with the fourth quadrant. Since in the fourth quadrant, the value of X comes from OX, so it is positive, and the value of Y comes from OY dash, so it's negative. This gives us the fourth quadrant, the first quadrant, wherein the coordinates are both positive. The second quadrant, wherein the value of X is negative but the value of Y is positive. The third quadrant, where the value of both X and Y is negative, and the fourth quadrant, wherein the value of X is positive but the value of Y is negative. We must always remember, by seeing at the values of the points, we should get a fair idea in which quadrant they lie. x, o, x dash is called the x-axis or abscissa. So this positive value, this negative value, this negative value and this positive value are all called abscissa. Y, O, y dash is called the y-axis or ordinate. So this positive value, this positive value, this negative value and this negative value are all ordinates. An abscissa and an ordinate when comes together makes a coordinate. An abscissa and an ordinate when come together makes coordinate. The point O is the origin of the plane and its coordinates are 0 and 0. So always remember the O, the intersection of x and y axis is O, and the coordinates of this point O here is 0 and 0. Now let us get to the core content, that is calculation of distance between any 2 points. Let P and Q be 2 points, P whose coordinates are x1 and y1 and Q whose coordinates are x2 and y2. We can follow here, the x is always put before y. X is always put before y. In other words, the abscissa is always put before ordinate. So if P and Q are any points in the xy plane, P, Q, xy plane, the distance between P and Q would simply be called PQ. Let us see this over a graph. We can see our x-axis here, our y-axis here. The point P is x1 and y1. The point Q is x2 and y2. The value from origin till this point is x1. The value from origin till this point is x2. Value from origin to this point is y1, and the value from origin to this point is y2. So if this much is x1 and this much is x2, the value of this line would naturally be x2 minus x1. Similarly, if the value of this is y2 and this is y1, the remaining portion would be y2 minus y1. The formula for distance then becomes PQ is equal to root over x2 minus x1 squared plus y2 minus y1 squared. x2 minus x1, which is this value, and y2 minus y1, which is this value. We square this value, add them up. Square root of that is the distance between P and Q. If the graph is in centimeters, the value becomes centimeters. If the graph is in meters, the value becomes meters. Otherwise, the unit remains units. As we can notice that the distance formula PQ is a simplification of the Pythagoras theorem. Hypotenuse squared is equal to perpendicular square plus base square. We take the base, we square it up. We take the perpendicular, we square it up and add a root over it. Using this formula, understanding this formula will become easy with the help of an example. So the problem statement goes, the given points are A, 6, 8 and B, minus 10, minus 8. Remember students, after reading the question, first instinct should be to gather the data points, which is A, 6, 8 and B, minus 10, minus 8. So we have two values for abscissa or x, which is 6 and minus 10, and two values for ordinate or y, which is 8 and minus 8. So let's write them down. x1 is 6 and x2 is minus 10. Similarly, y1 is 8, y2 is minus 8. Let us plot this on the graph and see. As x1 and y1 are both positive, the point lies in the first quadrant. As x2 and y2 are both negative, the point lies in the third quadrant. 6. So from the origin, which is 0, we go 6 points ahead. 1, 2, 3, 4, 5 and 6. Similarly, y1 is 8, we go 8 points up. The points meet at this point, which is x1 and y1. Similarly, the x2 and y2 is plotted here. The distance between the 2 points AB is equal to root over x1 minus x2 squared plus y1 minus y2 squared. Let us substitute the values of x1, x2, y1 and y2. We get 6 minus x2 is minus 10, so minus of minus 10 squared plus 8, which is y1, minus y2, which is minus 8. Minus 8 here. Solving the first bracket, we get 6 minus of minus 10 is plus 10 squared plus 8 plus 8 squared. 6 plus 10 is 16, 8 plus 8 is 16, the square of both. Root over 512 units, which is 22.63 units. So the distance between the 2 points is 22.63 units. Now let us see the distance of a point from origin. Specifically from origin, earlier we had two distinct points, P and Q. In this case, we have a point A and the other point is simply the origin, 0, 0. So if A, which is a point xy, be any point on the xy plane, and O, which is 0, 0, is the origin of the same plane, the distance between A and O is AO. Let us understand this with the help of a graph. So, on the x and y plane, if one of the point O is simply the origin and the other point is A, which is x and y, the distance is AO, and AO is equal to simply root over x square plus y square. How did we get this? From the distance formula. We know from the distance formula that the distance between 2 points is x1 minus x2 squared plus y1 minus y2 squared. x2 and y2 are both 0 here, so we put 0 and 0 and simply get the value as root over x squared plus y squared unit. This will again become simpler if we solve an example. Find the distance of the point A, 6, 8 from the origin 0, 0. Naturally, first we will gather the data. A is 6, 8 and the second point is simply O, 0, 0. Naturally, x1 is 6, x2 is 0, y1 is 8, y2 is 0. Plotting this over the graph, we see on the x and the y axis, one point in the origin, O, 0, 0. The point A is 6 units and 8 units, which meet here, 6 and 8. Distance between the point AO will be equal to x1 minus x2 squared plus y1 minus y2 squared. 6 minus 0 squared plus 8 minus 0 squared, which is simply x squared plus y squared. 6 squared is 36 and 8 squared is 64. The sum of both these numbers is 100, and root over 100 gives us 10 units. So we get the distance from A to O is equal to 10 units. Another example. Coordinates of the center of a circle are 0 and 0, which is nothing but the origin. If the coordinate of any point on its circumference is 5 and 12, find the radius of the circle. Since the point 5, 12 is on the circumference of the circle, the distance between P, we are assuming that the point 5, 12 is any point P, and 0, 0 is the radius of the circle. Collection of data: x1 is 5, x2 is 0, y1 is 12, y2 is 0, x1, x2, y1, y2. This becomes easier if we understand with the help of a graph. This is a circle, the x and the y axis. This is the origin. There is any point 5, 12. Since both of these are positive, we have taken them in the first quadrant, P, 5 and 12. So the distance from origin to this point, which is lying on the circumference of the circle, will give us the value of the radius. 2 points or the radius of the circle is equal to minus x2 squared plus y1 minus y2 squared. Substituting the values, x1 is 5, y1 is 12. Since the distance is calculated on the basis of origin, we simply have to add the squares of the two terms, 5 squared plus 12 squared. 5 squared is 25, 12 squared is 144. Root over 169. Root over 169 gives us 13 units. So the distance between P is 13 units, or the radius of the circle is equal to 13 units. If its center is at the origin and any point on the circumference is 5, 12. This brings us to the end of this chapter.